In this video, I am going to solve this second order non-homogeneous differential equation, and this is the differential equation. As you may already know, that non-homogeneous differential equations, to solve them, we kind of divide them into two different pieces. One is the homogeneous part and the other is the non-homogeneous part, and then we get solutions for both of them and add them up to get the ultimate solution for the differential equation, or general solution for this differential equation. And the way we write it is y of t is equal to y sub h of t plus y sub p of t. Here y sub h of t is the solution, general solution to the homogeneous part, when instead of e to the power t on the right hand side you have 0. Okay, and y sub p of t is one particular or one specific solution to the non-homogeneous differential equation, that is when you have e to the power t on the right hand side. Now let's first go ahead and solve the homogeneous part, which is very easy. So corresponding homogeneous equation would be here y double prime minus 4y prime plus 3y is equal to 0. And our assumption would be that our solution to this homogeneous differential equation is going to be of the form y is equal to e to the power rt. Then we are going to go ahead and take the first and second derivative and plug in those values into this equation. If we do that, we get the following, this equation. And as you know, the derivative of e to the power rt is going to be r times e to the power rt, and the second derivative is going to be r squared times e to the power rt. If we take these three values and plug it into here, we get this. Now e to the power rt is not equal to 0 because it's an exponential function. So since the right hand side is 0, it must be the case this guy is equal to 0. Okay, and this is a quadratic equation, so we can solve it by either factoring or by using the quadratic formula. Now, if we solve it, we get R1 is equal to 1 and R2 is equal to 3. So my solutions are going to be e to the power t and e to the power 3t. So homogeneous solution, general format of the homogeneous solution is going to be y sub h of t is equal to c1 times e to the power t and c2 times e to the power 3t. Okay, where c1 and c2 are some constants. Now let's go ahead and make some assumptions on the solution to the non-homogeneous part of the equation, right? When we have on the right hand side e to the power t. So let's say I assume it to be my particular solution, y sub p of t is equal to a times e to the power t. Now what I'm going to do, I'm going to go ahead and plug it into this equation by taking the first and second derivative. So what is it going to be? A times e to the power t, because double derivative, okay, minus 4 times a times e to the power t plus 3 times a times e to the power t. If I simplify it, well, that's supposed to be equal to 0, of course. Sorry, not 0, e to the power t, right? So if I simplify it, on the left hand side, I get 0 is equal to e to the power t. That's not true. We have a problem here. How do we go about solving this problem? Obviously, e to the power t is never 0. The first question I should be asking, or we should be asking, why am I getting that? Because right hand side is e to the power t, so the solution, particular solution, should be of the form a times e to the power t, which worked previously. But how come it doesn't work here? The reason that it doesn't work here and gives me inconsistent answer, okay, is that, look here, e to the power t is actually already a solution to this differential equation, but the homogeneous differential equation. So that means whatever we have on the right hand side, e to the power t, is actually a solution to the corresponding homogeneous equation, which is this. So, of course, that has to be equal to 0, right? So, this right hand should be 0 to be consistent with the left hand side. So, this cannot be a solution. Now, we run into a problem. What do? So, we will kind of play a little game that we did play before. So let's say my y sub p of t is going to be not of the form a times e to the power t, but rather a times t times e to the power t. Now I'm going to take this y sub p of t and take the first and the second derivative and then plug it into this equation. If we do that, we get the following. So I took the first derivative of y sub p of t, which is a times t times e to the power t, and I took the second derivative and put it into this equation and simplified it. And after I did the algebra, I got negative 2a times e to the power t is equal to e to the power t. Since e to the power t and e to the power t on the right and left, they're like terms or similar terms, then the coefficients must be the same, right? So on the left hand side, coefficient is negative 2a, and on the right hand side, coefficient is 1. That gives me a is equal to negative 1/2. Therefore, my particular solution is going to be y sub p of t is equal to negative 1/2 t times e to the power t. Then my general solution is going to be sum of these two, right? So y of t is going to be c1 e to the power t plus c2 e to the power 3t minus 1/2 t times e to the power t. And that is going to be my final solution or general solution for this second order non-homogeneous differential equation. I hope that this discussion was helpful. Thank you very much.